In this section, we will talk about the measurement of physical quantities. Here, we must be aware that no instrument is perfect. Meanwhile, no measurement is perfect either. Therefore, measured physical quantities do not reflect their true values. In other words, the measured physical quantities are inexact. The difference between the measured value and the true value is called the error. E is defined to be x minus mu. Pay attention to the sign of the error. If the measured value is greater than the true value, the error is positive. If the measured value is smaller than the true value, the error is negative. According to the origins, there are two types of errors. A systematic error is the repeated value of error in every measurement when the instrument is used in the same way and the same environment. That is, a systematic error is a constant if the measurement is done in the same way and in the same environment. Here, we use the measurement of somebody's height as an example. When measuring one's height, the observer checks the top of the head with the ruler. But if the observer reads the ruler at a lower angle, he or she will overestimate the height. If the observer reads the ruler in the same way all the time, he or she makes systematic error. Another type of the error is the observation error. The observation error is sometimes called a statistical error. It is the random fluctuations of measured values. Observation errors are unpredictable. For example, the observer cannot repeat his or her position every time. So, there is some random and unpredictable fluctuation to the measured heights. As we have seen, wrong methods in measurement introduce systematic errors. The environments also affect the systematic errors. The systematic errors can be reduced by calibration before measurement, but imperfect calibration may also introduce systematic errors. We use the grandfather clock as an example. The grandfather clock uses the period of its pendulum oscillation to measure time. The period of the pendulum mainly depends on its mass distribution. The mass distribution can change with temperature, corrosion, and dust collection. The change of air pressure, gravity, and friction may also change the period. As a result, the period of the oscillation of the pendulum changes over time. It introduces a systematic error. The calibration can be done by adjusting a little knot on the pendulum, which changes its mass distribution slightly. If the ith measurement gives the value xi, the expected value is the sum of all the measured values divided by the number of measurements. The expected value is also called expectation, average and mean, etc. The error of the ith measurement is xi minus mu. It is the sum of the systematic error and the observation error. Pay attention that the systematic error is a constant, while the observation error changes from one measurement to the other. Since the observation error is random, if the number of experiments is big enough, the expected value of observation error is 0. Therefore, if the number of measurements is big enough, the expected value is the sum of the true value and the systematic error. In other words, the observation error can be eliminated by a large number of measurements, but the systematic error cannot. The residual of the ith measurement is defined to be the difference between the measured value and the expected value. In statistics, the standard deviation is defined by the following equation. The standard deviation is a measure of the degree of fluctuation or dispersion of a set of values. Note that residual and standard deviation could have different definitions in other fields. The term accuracy describes how close the true value and the measured value are. Good accuracy corresponds to a small systematic error. The term precision describes how close the measured values are from each other. Good precision corresponds to a small standard deviation. For example, suppose there is a tennis ball whose true mass is 54.45 gram. A bathroom scale has a sensitivity of 0.1 kilogram. The measured masses are 0.0 kilogram every time. Thus, it has a poor accuracy, but its precision is good. A kitchen scale has a sensitivity of 1 gram. The measured values have good accuracy but poor precision. Finally, the measure values from an analytical balance have both good accuracy and good precision. The concepts of accuracy and precision can be also understood from this figure. The final example is the measurement of the resistance of a conductive glass by me and 7 students. I measured the value 7 times. You can easily find that the expected values from me and the students are quite different. This is because I and the students used the different techniques. So, we had different systematic errors. You can also find that my standard deviation is much smaller than the students'. It is because my technique was relatively consistent, but the techniques of the students were varied.